Probably the another subject that has involved philosophers for quite a long time, and it's probably fostered a lot of interaction between the scientific community and the philosophical community is the question of the brain and how the brain works. And probably the most interesting things of all have been the models that have come forth through the century as to how the brain actually behaves. What's actually going on in your mind when you actually perceive a given object or have a given idea. Probably the most interesting model that has come about, especially in the mid to late 20th century, with regard to the brain. And this goes a long way from the 18th and 17th century ideas of the homunculus in the mind, as we had many philosophers honestly believe that they were men, or shall we say, cognizant men that existed within the brain that were responsible for the emotions and for the rational functions of the mind. And these homunculi were responsible for individual thoughts and emotions and preferences, opinions and beliefs, etc. The reductio ad absurdum was that each homunculus therefore had a smaller homunculus within its own brain that altered its emotions and altered its rational states, etc. And this reductio ad absurdum didn't sit very well as the Enlightenment passed over the Western tradition and led us into believing that, especially with La Mettrie and others who believed in the mechanization of the human body and the human mind. Such great discoveries in adding machines, such as Blaise Pascal's adding machine and Leibniz's computer, or shall we say primitive computer, as well as the work of Alan Turing, led many to start to think of the brain in terms of computation. That is, start to think of the brain as being a computer, and psychology as merely being the software. That is, the pattern by which the computer determines what it should compute and what its output actually is. And this philosophy was called functionalism, or referred to as functionalism, and found its late 20th century proponents in the persons of Hilary Putnam and John Searle, both of whom now in the waning stages of the 20th century have referred to functionalism as metaphysical realism, or as metaphysical nonsense, so to speak. That the brain can be described as just a set of individual adding machines isn't acceptable within the view of emotivism and the revolutions that have come about in linguistics and cognitive psychology. The Turing machine model, or shall we say the functionalist model, sought interactions between individual Turing machines that churned out questions to logical propositions impinged upon the brain by the environment, or given to the brain by the environment. The Turing machines were able to give the human brain complex emotions because they interacted dependently upon each other. That is, they interacted cooperatively. But the view that a Turing machine can give rise to grammars, or shall we say, give rise to patterns of logic that do not adhere to given semantic requirements. That is, emotions, for example. How can one possibly generate a grammar or generate a scheme of logic that expresses something that isn't in and of itself irreducible to the tenets of logic? Obviously put the functionalists on the defensive. Further advances in actually understanding the structure of the brain by such biological researchers as Ramon y Cajal and Camilo Golgi, and works in important linguistics experts such as Chomsky and such as Ludwig Wittgenstein and Saul Kripke, have given further evidence that the structure of the brain and ideas with regard to the construction of grammars make it much more complicated than merely the idea of a computer set to 0 and then given some very basal set of instructions and then allowed to interact with neighboring computers or neighboring Turing machines to produce emotion, has come about in a fashion that has weeded out a lot of the weak points of the brain-computer continuum and brought into the idea of innate structures within the brain. These coming from Chomsky, whose ideas of an innate grammar, that children, for example, learn language because there are structures within the brain that pre-exist or predate experience with vocalization, and have been proven or have been shown with very little doubt on the part of cognitive scientists, neuroscientists, and cognitive psychologists. So the belief now has resided in not necessarily a brain that is composed of interacting Turing machines, but a dynamic brain, a brain that is shifting. The Nobel Prize winner Gerald Edelman came up with the idea of neural Darwinism, the idea that instead individual nuclei, that is collections of cells within the brain, compete with one another whenever a new stimulus is introduced into the brain. And this view has been taken up by Paul and Patricia Churchland, and also by the other Nobel Prize winner, Francis Crick. The idea that whenever a new experience enters the brain, those nuclei that are best adept at handling it are the ones that fire, that interact with one another, and that in that firing they generate an environment that behooves their existence, and that those neurons within the brain that are not so adept at handling the new information, or not continuously in process of generating internal functions, that is thoughts, recollections of thoughts, memories, etc., or involved in motor processes or involved in emotional processes, wither away. And that is the survival of the fittest among collections of cells within the brain, such that the brain is shaped by the continual uses of emotion, habits, constantly, or new signals from the environment that repeatedly stimulate pre-existing nuclei that are predisposed to the sequence of events that comes with a certain experience. And that the brain is therefore shaped, first of all, by the tendency of given sets of cells to be predisposed a priori, that is, innately predisposed to receiving a certain experience. And that if that experience then comes about in the subject's lifetime, then those collection of cells or those nuclei are reinforced, and that therefore they shape the architecture of the brain by already having the code within them, so to speak, the computer code already within them. All they need is for the environment to press the metaphorical button. This view of the brain has been challenged on some rather superficial levels, just on the basis of biologists unable to see distinctive changes in neural architecture over the lifetimes of given patients in which they have studied. But this is yet to offer a very substantive obstacle in the further development of ideas of the brain.